A new chapter in cosmic history has just unfolded. Astronomers have received extraordinary new images of 3I, Atlas, the third interstellar object ever seen, a lonely traveler drifting through our solar system from the vast unknown beyond. What these new observations reveal has astonished scientists across the world, opening up deeper questions about how much we truly understand the universe around us. Until recently, humanity had never even seen a visitor from another star. The story of interstellar travelers began only a few years ago, and each arrival has rewritten the limits of what we thought possible. The first was Oumuamua in 2017, a mysterious, cigar-shaped object that entered our solar system silently, accelerated in strange ways, and left as quickly as it came. Its movement could not be fully explained by gravity or gas jets, leaving scientists wondering what forces guided it. Next came Comet Borisov in 2019, far more familiar in appearance, with a classic glowing tail. But its chemical makeup was anything but ordinary. It carried the fingerprint of a planetary system completely different from our own, the frozen signature of a distant star. And now, 3I, ATLAS, an object even more complex, erratic, and mesmerizing than those that came before it. When astronomers turned the James Webb Space Telescope toward this strange visitor, their goal was simple: study its dust, measure its speed, and identify the materials within it. But what Webb revealed went far beyond expectation. For the first time, scientists witnessed an interstellar body showing irregular accelerations, quick changes in motion that could not be explained by sunlight, gravity, or outgassing alone. Instead of traveling in smooth, predictable arcs, 3I, ATLAS seemed to move with intent, twisting, slowing, even briefly changing direction, as though obeying some hidden rhythm written into its core. Infrared data showed faint plumes of gas bursting from its surface. But instead of forming a neat comet tail, the emissions scattered chaotically, fragments and jets flying off in multiple directions, as if the object pulsed like a heartbeat in space. The chemistry deepened the mystery further. Webb detected rare carbon compounds, microscopic silicate grains, and ices unfamiliar to our solar system. All signs pointed to one conclusion: 3I, ATLAS was born in another star's nursery, likely in a part of the Milky Way shaped by more violent radiation and colder dust than our own region. This makes it far more than a comet. It is a frozen time capsule, carrying with it the chemical story of another world. Yet something didn't add up. Some of its shifts in direction happened with no visible jetting or venting, suggesting forces at work that remain beyond current explanation. Most researchers believe natural causes are likely: trapped gases, internal fractures, or crystalline energy releases, but the irregularity of its motion still feels almost deliberate. For that reason, 3I, ATLAS has become more than just an interstellar visitor. It is a moving experiment, a drifting laboratory teaching us about the hidden machinery of matter born around distant suns. And it may be more than that: a cosmic courier spreading molecules across the stars. Every plume of gas or dust could represent the seeding of chemistry, releasing complex compounds that might one day form the. For centuries, humanity has wondered how life began, whether it was born here on Earth, or if it came from somewhere far beyond our skies. This mystery connects to an ancient and daring idea known as panspermia, the theory that life's essential ingredients are scattered throughout the universe. That the molecules of biology, carbon chains, amino acids, organic ices, are carried across the stars by comets, asteroids, and fragments of frozen dust. Each one a vessel of chemistry, a messenger of potential. Now, with the arrival of 3I, Atlas, this idea no longer feels like distant speculation. It feels tangible. Because this interstellar traveler has already proven it carries complex, carbon-based compounds, materials not native to our solar system. If 3I ATLAS can preserve such fragile molecules while drifting through deep space for millions, or even billions, of years, then it could also release them when it passes near a star like ours. Each burst of gas, each jet of dust it ejects into the cosmic wind, could be spreading the raw materials of life into new worlds. Perhaps this is how the seeds of life move between stars, hidden inside fragments of rock and ice, surviving the void, waiting to awaken when they finally find warmth again. And if that's true, then maybe Earth's story is not unique at all. Maybe life is not a single miracle, but a pattern repeated across the galaxy. A quiet rhythm echoing wherever chemistry and time are allowed to dance together. Life, in this view, becomes a galactic phenomenon, something that does not belong to one planet or one star, but to the universe itself. Every comet, every interstellar wanderer could be part of a great cosmic exchange, a network of worlds sharing ingredients, shaping new beginnings. But 3I ATLAS doesn't only challenge our understanding of biology. It also forces us to rethink physics. For generations, astronomers believed comets were simple machines, predictable bodies governed by the laws of gravity and sunlight. We thought we understood how they moved. Ice turns to gas, gas escapes, and the comet gently adjusts its path. Yet 3I ATLAS refuses to follow that pattern. Its movements are erratic, filled with sudden bursts of acceleration, unexpected pauses, even brief reversals of direction, changes that seem far too complex to be explained by normal physics alone. Something is happening deep inside it, something hidden. Perhaps layers of ice and rock are trapping gases that suddenly erupt like tiny engines. Or maybe there are intricate tunnels of crystalline material within, opening and sealing like natural valves. This means that interstellar comets are not just frozen fossils drifting in space. They are dynamic, living systems, intricate, reactive, and full of motion. They are cosmic laboratories, carrying within them the energy of creation and destruction, responding to the invisible forces that sculpt the universe. And this realization carries enormous importance for the future of exploration. Because if humanity ever dares to send a spacecraft to intercept an interstellar visitor like 3I Atlas, we'll be facing an object unlike anything we've met before. Imagine a spacecraft approaching a target that can twist, spin, or pulse without warning, reacting to internal forces that cannot be predicted or modeled. Traditional guidance systems would fail. By the time a signal travels to Earth and a command is sent back, the object could already have shifted its path. Future missions will need to be autonomous, guided by artificial intelligence capable of making decisions in real time. They'll have to sense, adapt, and respond instantly to the heartbeat of a living, moving object. So in this way, 3I ATLAS doesn't just expand astronomy. It reshapes how we think about engineering, robotics, and the limits of control. It challenges us to build machines that can think, move, and react as nature does, fluidly and instinctively. But beyond all technology, beyond all science, 3I ATLAS touches something far deeper, a philosophical truth. It reminds us that the universe is not uniform, not calm, not predictable. Each solar system is its own experiment. Some form in gentle nurseries of dust and gas. Others are born in violent storms of radiation. Some trap exotic minerals and ices never seen on Earth. And some, like the one that gave birth to 3I ATLAS, carry the echoes of stars that died long before our sun was born. By studying this one erratic wanderer, we gain a glimpse into the enormous diversity of creation scattered across the Milky Way.